going on, guys? In this video we are going to see how to solve a first order homogeneous differential equation. Now the first thing we have to do is we have to make sure this is a first order homogeneous differential equation. To make sure, what we have to do is we have to equate this dy over dx to this function, and the function after this equal sign would be able to can be able to written in y over x pattern. So let's see whether we will be able to write this one in terms of y over x. To do that, what we can do is we can multiply 1 over x square both sides, up and down. So this is going to be 1 over x square, 1 over x square, and if you multiply this one, you will get 2 times y over x, and in the bottom we are going to have y square over x square. So we can combine them together and write it like y over x whole square minus 1, right? So this is what we are going to get. So from this one we already know we were able to write this one in terms of y over x. So this is definitely a first order homogeneous differential equation. So now what we have to do is we have to equate this y over x values to v. That's our next step. So here v is equal to y over x, and this dy over dx is equal to x dv over dx plus v. So dy over dx is equal to x dv by dx plus v. Now we can write everything in terms of v. So let's go ahead and do that. So this is going to be x dv by dx plus v, and then other side of the equation we are going to have 2. Instead of y over x we are going to plug v right here, and in the bottom we are going to have v square minus 1, right? So this is what we are going to have right now, and yeah, this is what we have. Let's move this v to the other side and see what we get. So this is going to be x dv by dx is equal to 2v over v square minus 1, and if I move this v to this side, that's going to be minus v, right? And this is what we are getting. And then let's write this one in better way. We can combine these two together. We can take this v square minus 1 as common denominator. If we take that one as common denominator, this is going to be 2v minus v times v square minus 1. So this is what we are getting. Let's simplify this one. So this is going to be 2v minus v cube minus v over v square minus 1, and that's going to be equal to 2v minus v, that's going to be plus v. So 2v plus v is going to be 3v minus v cube divided by v square minus 1. This is what we are getting in this side. Okay, so this is what we are getting. So now the next thing is we have to integrate, but here we have a dx right here, dv right here, right? So what we have to do is we have to bring this to the other side and this x values to this side. In that way it's easy to integrate, right? So let's go ahead and do that. So first of all we have to bring all the x to one side. So it's better if we bring this side, because we are going to have 1 over x dx. Dx should be in the numerator, then only we can integrate and find the values, right? So first let's bring the v's to this side. So this is going to just flip around. So we are going to have v square minus 1 on top. Let's write this one with different color. V square minus 1 on top, and then in the denominator we are going to have 3v minus v cube and also dv, right? dv. In the other side of the equation we are going to have 1 over x dx. So this is what we have. Now we found out this is separable. Now all we have to do is integrate. So this is integrate of this one, integration of this one, and here if you notice we have the derivative on top here, because here we have v cube and v square. So derivative on top, so we can do the u substitution. We take this denominator as u, so this is going to be 3v minus v cube, and if we find the derivative of this one, that's going to be 3 minus 3v square. And here what we can do is we can factor this by, if we take negative 3 common, this is going to be v square minus v square minus 1. And if I move this negative, so this is also dv right here. And if I move this negative 3 to this side, this is going to be dg divided by negative 3 is equal to v square minus 1 du. Now we can go ahead and write everything in terms of u. So this is going to be, the first one we know that is a v square minus 1 dv on top, and we found out v square minus 1, this is dv. dv is equal to dg over minus 3. So we can take this 1 over minus 3 in front, and inside the integration we are going to have dg here, and we have 1 over 3v minus v cube remaining, that is equal to u. So this is going to be 1 over u right here, right? And if you integrate this one, this is going to be just ln u, ln absolute value u, and also we have negative 1 over 3 right here. And then if we back substitute this 3v minus v cube, that's going to be 1 over 3 ln 3v minus v cube. So this is this side of the equation. Other side of the equation we had integration of 1 over x dx. So this is going to be ln absolute value of x, right? So this is equal to ln absolute value of x. Now to get rid of this ln side, ln signs both sides, we have to we can e power both of them. So this is going to be e power minus 1 over 3 ln 3v minus v cube, and this is going to be e power, and also we have to put a constant right here, right? We should put constant both sides, but if we combine them together, we can combine them together and put it as c, right? So that's going to be c right here. And then here we are going to have e power ln x plus constant, and this one we cannot now just eliminate this e and ln. We have to do something with this minus 1 over 3. So what we can do is, if we move this one to this side, that's going to become a power. So this is going to be just 3v minus v cube power minus 1 over 3, and after we move this power, this is going to be e ln of this power. So e and ln cancel, we will end up with this one, and here we just end up with e ln x plus c, and e ln x is plus c is basically e ln x times e power c, right? Because we know that when we have two power adding, that means that's a multiplication. So this is same as e power ln x times e power c, right? So this is one. Let's say e power c is equal to c1. So we can write our new constant as c1. So this is basically this one, and this is going to be just x, and this is going to be our c1, x times c1, and here we have this one. Now what we can do is we can multiply this one by negative 3. So if I multiply this one by negative 3, that's going to become positive 1, right? So negative 3 both sides. So this will become power negative 3, and this will become 3v minus v cube. So we have almost reached the final part, and also here again, instead of c1 power negative 3, we can say c1 power negative 3 is equal to c2, and we can just write c2 right here. And final answer should be in terms of x and y, because initially we had x and y only, then we replace that one with v. So we had to bring this one back, and we know that v is equal to y over x, right? So what we can do is we can write this one as 3 times y over x minus y cube over x cube, and here in the other side we know that this is going to be 1 over x cube, we got x power minus 3 is 1 over x cube, and we found out c1 power minus 3. We equate that one to c2, so we can just write c2 right here. And if we multiply this x cube this side, that's going to become 3x square y. So this is going to become 3x square y minus y cube is equal to c2. And this is going to be the general solution of this differential equation. I hope you guys find this video helpful. See you next time.